Okay, so here's notes continuing in 3.3. So it's the same properties we were doing, it's just to do two different skills. So I don't know how much success you had with homework. We can look at homework in a little bit. Yesterday you more or less had to like draw some Oscar had a heap of apples pictures and then try to do stuff with these properties. Today what we're trying to do is solve some equations with these properties. If you have the notes that I gave you last time that had charts and general formulas on it, that's always a good thing to have around because I will refer back to that today. But here's what we're after today. There's some sort of a big giant trig thing that you're trying to solve an equation and figure out what theta is. Some of the problems will have thetas, some will have x's. As always, theta is a code for degree time. X is a code for radian time. So the first thing we're going to have to do is take this ginormous trig thing and just shrink it down by recognizing what property is. So 3.3 is going to do this, 3.4 is going to do this, 3.5 is going to do this. The only variation from lesson to lesson is going to be which property family we're using. So this, which property goes sine, cosine, cosine, sine? Is that a sine, a cosine, or a tangent? That is sine. We'd use the theta, we'd use the 10, and then we just finished taking the quiz. Hopefully you had success. Is this the one where we keep the plus? Or is this the one where we flip-flop that into a minus? Flip-flop. No, keep is right. I disagreed with myself and then changed my mind. It is, we keep. There was enough of a scramble here. Sine, cosine, cosine, sine, that's all scrambly. All the words are intermixed and intertwined. So the sine properties, where there's a bunch of stuff that's all like mixed up, we do keep the sine. That is correct. So that's our first move. I think you'd agree that is better looking. It just got smaller, faster. Smaller is good news. Question about property recognition. Step 2, we're trying to solve for theta. So, algebra motif. You're always trying to do the opposite. So to get rid of sine and just leave theta plus 10, we're going to need to do a couple things. One is to do an inverse. Okay, so we're going to do inverse sine to cancel sine. When we're doing inverse sine of this crazy fraction, which should be familiar to your life, where do we look to do inverse sine of this thing? Where does that answer live? The inverse sine of root 2 over 2. What tool could we use to decide on who is the inverse sine of root 2 over 2? The chart. We're going to use our chart. Use the degree part of your chart, because this is a degree question. Sine, root 2 over 2, who does that lead you to? 45. That's one answer of an endless amount of possible answers. So we need to also refer back to last chapter. We had a thing called general solutions that I have on that notes paper that I gave you in the previous lesson. The general solution for sine is take what the chart gave you, plus 360k, and then how do you do the other half of that? Also plus 360k. Memories of the general solution sign, how that worked? 180 minus. 180 minus that 45 is 135. So there's a lot of action in that step, but it'll always be, you'll have to do an inverse. Doing an inverse is going to make you peek at your chart. The chart can give you one answer of an endless possibility. Then we have to use those general solutions to express a variety of things. And then we're one step away. Question about that, so forth. Then you just do one more opposite. You would do some kind of adding or subtracting opposite. This was an adding property, so we're going to have to subtract. If we had a subtracting property, you'd have to add. So to get the theta alone, we need to subtract 10. I can subtract 10 from this because that's just a number. I can't subtract 10 from this because those are unlike terms. This has k, so 10 didn't have a k. I just have to leave that alone. Can I subtract from this? Yeah, so 145. Change this or keep? Keep. And this is what we've been seeking. They won't make you make a list of answers. But if they did want you to make a list of answers that work, 35 works, because that said so. 125 works, because that said so. 360 added to this to get 395 would work. If I add 360 to this to get 485, that works. If I wanted to add 360 twice to this to get 755, that works. And I could sit here all day and do that. I'm not going to sit here and do it all day and do that. This is the only way you can really quickly describe what all the answers look like without making an endless list. Question about what was up with that? If I lost you, I'll make up another one on the spot and do it. I had one in my notes, but I could make up other ones and do it. But it'll always boil down to recognize a property, do an inverse, which will lead you to the chart, which will lead you to a general solution, and then some, I should have said opposite here, add or subtract, opposite, some kind of opposite of the other. If you get it, I'll move up. If you don't get it, we'll make up another one. What's your opinion on this? Maybe another one? I'll just do one down below. I think I can squeeze that one. I might run out of camera range. Anybody still copying that top one? Can you leave it? So I'm going to go cosine, cosine. Minus sine, sine. I'll do that. See how it works. I don't know. This might get messy because I'm just making it up, but we'll hope for the best. So we've got to recognize what property is that. If I go cosine, cosine, sine, sine, that is a cosine. I've got an x, I've got a pi over 2. Is this the one where we keep the minus or we switch it up? This one we switch it up. So that's our property recognition. Good with that? Anybody? Really? And we're going to do an inverse. When you do an inverse, it's basically erasing the cosine to leave the parentheses. And then we check our chart. Cosine, radian column, half. You tell me, maybe you've got a chart handy. Pi over 3 is true. And then I'm going to do a general solution in a second. Did the pi over 3 bother anybody? What do we surround this with to do a cosine general solution? Plus or minus that number, plus a 2 pi k. I agree with that. Question about that? Then in the final analysis of this, how are you going to get that x completely alone? How are we getting this out of there? Subtract pi over 2. We have two different numbers to deal with, though. So I'm going to take a side trip right here. There's a positive pi over 2. No. There's a positive pi over 3 that needs to subtract pi over 2. But there's also a negative pi over 3 that has to subtract pi over 2. We can't get those both at the same time. We're going to have to individualize those. So the positive fraction needs to subtract our pi over 2. The negative function has to subtract that pi over 2. We're going to get two different things here with the 2 pi k's on it. Like we're going to have to tear this apart essentially into its split personality. Something to re-explain there at all? How do you subtract fractions? You need a common denominator you pick would be 6's. If you're changing bottoms, change tops. So this would be 2 and 3. 2 minus 3 is negative 1. If you want to write the 1, go ahead. Pi over 6. Over here, you'd again pick common denominator of 6. Top again is going to be 2 versus 3. Negative 2 subtracting 3, though, is a different path. Negative 2 subtracts 3 is negative 5 pi over 6. Something there.
How do you know when the sign's going to switch at the beginning?
Cosine does, and sine does not.
And what about tan? Or does that
Tan, you go by the top sign. So if I wrote you tan x plus tan 30 over 1 minus tan x tan 30, that would become tan with x's and 30s. If I go plus here, you go plus there. If I want to go minus there, I have to go plus there, and then you've got to go minus there. It's just a matter of repetition, sorting that out in your memory banks, or just keep peeking. Just keep peeking at your paper and it has them on it. Something about that style of question that I forget the homework numbers. I think it's like 45 to 56. The first homework cluster, there's maybe about 6 of them like this. Here's a what if. They don't usually do this, but an occasional what if. Occasionally they'll throw on a negative. So if they throw on a negative, right in here, sometimes you have to deal with that negativity before you do the general solution. So if they threw a negative on there, on the notes it tells you. If I throw a negative on a cosine question, what adaptation do you have to make? If we're in degrees, yes, pi minus in this setting. So I'd have to take the pi over 3 that we agreed upon a second ago, and I'd have to go pi minus that, which this is over a 1, I'd have to force it to be over a 3, which gives that a 3, and that has a 1. We'd be dealing with 2 pi over 3. Then we'd still do that plus minus thing. But we'd have to settle up that negative right after you do the chart. You'd have to settle up what to do with the negative on that. That, again, that rarely happens, but it happens. It probably happens once out of the homework. Something there. Second group of homework brings back your old friend that we did on 3, 1, and 2 called trig identities, where there's 2 sides that they claim are equal and they want you to tell them how. So how did we do that on the quiz when we did from 3, 1, and 2? What was the name of the game on that quiz? You had to pick one of them and turn it into the other one. 53 in this homework is ridiculous. Okay, so I'm doing 53. Don't get scared by 53. The only way we would achieve 53 is probably by me doing the 53. Okay, so as we do 53, don't think, oh my goodness, I couldn't do 6 of those. Yeah, you couldn't do 1 of these, okay? The homework is not at this difficulty level. Okay, this one's bonkers. So the old homework, like 33, 34, this would be the equivalent of me teaching you that lesson by starting with doing number 33, 34 and like freaking you out. Okay? Don't get freaked out. Just sooner or later we need to get this one out of the way, and I'm just going to do that now because might as well do it sooner than later. But this will be like 4 times the length of any of the other ones you're going to have to do. What you're going to do is still Pythagorean, making sines and cosines is a good idea, all that stuff is still in there, but it is at some point going to use the new properties. That's why it's in this section, is to use those new ones. So, start on the left, start on the right. Somebody out there, you tell me. Start on the left. So, I'll sort of separate that off for a moment. We look to this. And then we need to have an idea about what to do with this side, because that's the side we picked. It could be an old idea. It could be a new idea. Anybody have an idea? We can do quotient. Okay, that's fine. So tan makes sine over cosine. I like that idea. That's a perfectly good idea. Sine over cosine is quotient properties, but in this setting, we need to keep these parentheses alive. If it's tan of a mess, that makes sine over cosine of that same mess. I'm marking beside there is a +1. I like it. Then we need another idea. Anybody have another idea? We can, okay, that would be fine. I would have also accepted common denominator as a perfectly good idea. We have a fraction that's adding a thing. To make a common denominator over here and put them together would have been perfectly fine. But this, if we just focus on the top, we have a property that you memorized. Sine goes sine cosine, cosine sine, with a maintained sign. Cosine, the stuff we just memorized, is cosine cosine with a switch of sign, sine sine, with +1 still lurking about. We'll just leave that go for a little bit. Welcome to Trig. You need something?
Yeah, Brian, you're gonna have to get it right with somebody else. Just does it, you know.
Okay, we'll get you. There's space, a bunch of places. Then we need another idea. I would not now suggest common denominator anymore because we just made this so big of a fraction. I don't think you'd want a common denominator with that fraction. Anybody have a suggestion of anything we could do there?
Or could you?
I'll tell you, we can attack these 4 things. So here maybe I'll write a note, I did like a sum and difference kind of property. Anybody have a thought on how I can attack those? See your chart. What is the cosine of pi over 4? Root 2 over 2. What's the sine of pi over 4? Root 2 over 2. Other stuff? Same. Everything has a root 2 over 2. So we could replace these all with root 2 over 2's. But if you have a math problem like ax plus ay on top of az plus aw, a memory of something that is like legal to do there? Take out the a from the top, and you could also take out the, and then what's going to happen? They're all going to cancel away. All of these a's, because they're everywhere, would cancel away. All of these would cancel away. Maybe say cancel. And then I'm looking at sine x plus cosine x on top of cosine x plus sine x plus a 1. Thoughts on that? Now we just need another idea. Maybe a common denominator now. That's not so ugly anymore. I feel like common denominator was probably inevitable. If we do a common denominator, I'd have cosine plus sine. This would be cosine plus sine on top of another cosine plus sine. So if we added that all up, we'd have what would you have? I feel like something went wrong. Think over what this would make. If you turn this into a fraction with the same top and bottom, this should have been a minus. That's why. So this had a minus there. I need to bring my minus there, bring my minus there. So you're imagining this to be this bottom having itself on top. Add that stuff up. Yeah, signs would eliminate, and you have two cosines. And I think at this point, as I've done this before, and I think I've been on this road, I think this is a point where I just like give up, start to try to work on the other side, and hope that I can meet in the middle somewhere. Because the only idea I have here is maybe to do a conjugate. But I don't feel like that's going to go anywhere in my life. This is sort of starting to resemble this because I have a cosine. And this has a cosine. But this has a 2 and some stuff. This has a root 2 and some other stuff. Like, I'm not sure where that's going to go. And I think that's where I fail. Let me take a peek at my paper and just see if I've ever done this way before and see if it says that. But that feels familiar-ish to me. But every year I do this by just like letting you guys make choices. So I don't know where you're gonna take me. I don't know. I don't see my paper. I don't know. I set it down somewhere, but I'm gonna switch sides. So I'm thinking, let's go after this. So, and like I said, this is 1,000 times harder than anything you're going to be asked to do. But if you understood that I can still use quotient properties, that the new properties got to appear, but things like the chart and canceling and common denominator and the skills that you've had before, they're still around. But if I go to work on this, I might say root 2 is going to be just sitting there. Cosine can sit there. And instead of a secant on the top, let me do a cosine on the bottom. That's basically just using a reciprocal property back to like the original advice I ever said. Originally I said sines and cosines are your friend, make them. So secant is not your friend. I'd rather have a cosine. And that looks a touch more like that. Like we're trying to meet in the middle. That's like not terrible. Anybody have a suggestion of something there?
Before that, if you were to do the cosine times secant and make that a 1, would that affect the...
No, because they're different. If it's cosine x and secant x, 1. If it's secant mess and cosine mess, 1. But since they're mismatched, no. It's a good idea, but anybody looking here with this suggested idea? Yeah, let's do that. Let's do this thing on the bottom with that sum and difference property group like we did a second ago. So I have root 2 cosine x. There we go. Cosine x cosine pi over 4 minus sine x sine pi over 4. Again, keeping an eye on where we're trying to go. These, they kind of look alike. We're maybe getting there. Suggestion on anything we can do to make this any better? We could go through some root 2 over 2s. So I've got a root 2 cosine. If we use our chart again, we're going to have a cosine x. Sorry for the squeaks. Root 2 over 2 minus a sine x. Root 2 over 2. Now that's starting to look pretty nice actually. Those are really looking a lot alike. A thought on a way you could turn a root 2 into a regular 2? Multiply by itself. So I could multiply by a root 2 on the top. And if I'm going to multiply a root 2 on the top, I have to do that on the bottom. So on the top, root 2 times root 2 is 2 cosine x. On the bottom, root 2 times root 2 is 2, but it's over 2. So 1 cosine x minus, what's going to happen here?
It's one of
It's going to be a 1 again, to be sine x. And lo and behold, sorry for the squeaks, one connects to the other. We could just sort of run this swoop this way, or we could run the swoop that way, but we definitely met in the middle. And again, likelihood of a high school student doing that would be 0. Likelihood of me doing it better because I've done it before, so I just have to try to remember some ideas and bail myself out. But another perfectly acceptable way we could have done this would have been to take, you have a tan A plus B property. You could have said at the beginning, take that tan A plus B and like blow that out. We would have still used the chart, and we would have still done some common denominators, but we would have been on a whole other road that has nothing to do with any of this. Okay? There would have been so many ways to do this, all of them would be hard. So you didn't choose unwisely. I think we made wise choices at every step, but it's just big. And again, nothing is like this. What the problems have in common is they will all use at some point one of these new problems. How much other stuff they use is going to vary, but again, nothing is close to this. But the second group of homework is pick a thing, turn it into the other thing.